What? I'm not playing with Legos. I'm using Legos to build an automatic beverage warming coaster. I'm an adult. What is up, everyone? Now, if you're keeping track of my videos, you'll know that a few videos ago I posted how to charge your phone with a candle. It was super fun, it was super cool, and it employed a technology that I am really starting to love, called the thermoelectric generator. This thing can turn a heat difference from one side to the other into an actual electric current that you could use, in that case, to charge your phone. But the coolest thing about these is that they work in reverse. Not only can you get a voltage from a heat difference, but you could run a voltage through the chip and get a heat change from the chip itself. This is super cool because that means one side of the Peltier device gets really hot and the other side gets really cold just by running an electric current through it. So we did the one end where we got current from a heat difference, so let's try the other end where we run a current through the chip and use its heat for something. How about a device that heats my drink? So we're gonna build a knockoff Lego coaster for our drink. We're then going to build it such that we can install this chip inside the coaster and it'll rest right on the drink's surface. We plug it in, it heats up, we have a nice warm beverage, everyone goes home happy.
I'm not happy.
But you're never happy.
It's gonna be wonderful. So, enough talking, let's get to building. What I'm gonna do is I'm gonna put two thinner strips on the bottom here, just to make sure that there's a little bit of space underneath this entire contraption. There, we have the chip, we have the channel, we have the airflow. Our coaster is ready to go. Now we just need to connect it to power. These Peltier chips are 12 volts, so all you have to do is buy a 12 volt adapter. Any kind will do. Strip the wire down to the metal and get some alligator clips and just clip them just like that. Just need metal contact. Now, if you want a more permanent solution, you solder them, which is what I did in my previous video where I made the cell phone charger. But for prototyping, for building small things, you want to see if they work, but you're not sure if you want to commit to using all your parts for this particular use. It's a better idea to try to use a non-permanent way of connecting them, like alligator clips, and then use what's called a breadboard, which is essentially just a place to connect temporarily your wires. So this breadboard is comprised of holes, and current runs vertically along each hole section. So what that basically means is that if I connect something here, and I connect another wire here, because they're connected to the same vertical slice, the current is gonna go through them. And that way you can design circuits without actually having to solder anything, which is primo for if you don't know if your thing is gonna work yet. So I'm going to connect the negative end of the Peltier generator to the breadboard, and then connect that to the negative end of the adapter. Then we're gonna connect the positive end to the positive end. So now as soon as you plug this thing in, it's gonna start getting hot immediately. If you want a little bit more intelligence, you can wire a button to this circuit, which could help if you don't want to be unplugging and replugging your device in every single time. See, what I want to know is how the heck do I not have a thermometer and I have to make my own thermometer? Arduino it up. Building thermometers to try to test the temperature because, God forbid, we have a thermometer at home. Blank means it's working. Go to the serial monitor. Woo! Except it's definitely not negative 273. Okay, I got it. It works now. While we're waiting, a fun fact about sort of Peltier chips is that it doesn't create heat, it transfers the heat. If you run electricity through something like a regular resistor, the impedance of current that the resistor gives will generate heat. That's why sometimes resistors that are very high voltage resistors can get hot. This is not what the Peltier effect is doing. What this chip is doing is actually transferring heat. The energy from the charge carriers on one side of the chip are rushing upwards towards the hot end of the Peltier chip. The consequence of that is that while one side gets very hot, the other side gets very cold. And if you would put your hand under here, under this contraption, the bottom side of the Peltier chip will be much cooler than ambient temperature, even though the top side is much hotter. So with the coaster finally made, it's time to put it to the test. I simply took a cup with some water in it, put my thermometer in, and tracked the temperature over a pretty long period of time. For time's sake, I'm going to show you guys the results after 1 hour of recording the temperature. Okay guys, I finished the experiment, and the experiment was a success, and now it's time for my favorite part of all of my projects, which is data analysis. Oh god, I love data analysis. Graphs, just give me graphs all day, every day. Let me see those slopes. Let me crunch some numbers because so good. I know that a lot of people check out or don't pay attention when I show graphs, but I love graphs so much. I just want to show one graph. It's gonna be great. So here is the graph that is, there's a number. Here is the graph of the temperature of our cup of water while it was on the coaster. And we can see, although it was super noisy, there's a clear trend going up to about 37 degrees Celsius. 37 degrees Celsius is like 90, 95, in that range degrees Fahrenheit, which is pretty warm. It's obviously not boiling, but that's more than warm enough to keep your drink at a reasonably warm temperature so that it doesn't just go cold on you if you want to leave it out somewhere and you kind of forgot to drink it. This will keep it at a very nice, comfortable 95 degrees, which is great. And if I left this on for longer, it might have even gotten higher. That was only an hour's worth of data. So this was such a fun project just to wrap up. If you guys like this idea but want to make it more portable, a great way to do so would be to solder a 9-volt battery connector to the ends of the Peltier chip. Now, it'll be slightly less powerful because it'll be 9 volts instead of 12, but it would allow you to take it with you instead of having it need to be by an outlet so you could actually plug it in. But otherwise, this was such a fun project, and I think the Lego coaster idea just looks cool. Like, it looks a little bit janky, but when you actually kind of think about it and have it set up, it like looks neat. It looks fun, constructed, kind of like a 5-year-old made it if a 5-year-old knew how to do electrical engineering. So, and it just looks so cute on top of a little coaster drink and have it be heated up. It's just adorable. I love it. So anyway, thank you guys so much for watching and for sticking with me this whole time. If you made it here, you are a person of science and you should be very proud of yourself. You even sat through all my graphs. That's crazy. No one ever sits through my graphs. So I encourage you to check out the other ways that I've used this Peltier chip, like how you can use the temperature difference to charge a cell phone. If you like this sort of content, definitely subscribe, give me a like, comment, and let me know what projects you want to see. I would love to take requests, and there's never a shortage of ideas when science is concerned. So until then, thank you so much for watching, thank you so much for tuning in, and see you later.